Let's go ahead and work through an example of finding a tangent line. So actually the derivative here. So let's find f prime of x for f of x equals the square root of x plus 1. And then I want to find the equation of the actual equation of the line tangent at the point 3, 2. And let's produce a graph of both functions. And I will go ahead and use Maple to produce these graphs. So what I need is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x, which in this case is going to be the limit as delta x goes to 0, square root of x plus delta x plus 1 minus the square root of x plus 1 over delta x. Now this is going to be a bit of a squeeze here. I didn't leave myself much room. Matter of fact, I need to rewrite this. I'm going to just switch here to some algebra. And I'm going to rewrite this as a square root of x plus delta x plus 1 minus the square root of x plus 1 all over delta x. And I'm going to multiply this by the conjugate, square root of x plus delta x plus 1 plus, you notice this is a negative, so this could be a positive, plus the square root of x plus 1 all over the square root of x plus delta x plus 1 plus the square root of x plus 1. So what I just did is this right here is equal to 1. So all I did was I multiplied by 1. Now when I did that, see, this is perfect, or difference of squares here. I multiply this out, and I'm going to get this squared minus this squared. So algebraically, this is going to be simply equal to x plus delta x plus 1 minus x plus 1. That's what this will be when I multiply it out. In the denominator, I will still have my delta x setting here, and that will be multiplied by the square root of x plus delta x plus 1 plus the square root of x plus 1. So I'm going to erase this equals here, and I'm going to put in here the limit because I really want to take this limit as delta x goes to 0. Now see, when I drop the parentheses, which obviously I can easily do here because the leading coefficient outside that parenthesis was a positive 1. Now when I drop this paren, I have a negative x and a negative 1. So I'm just going to erase that very quickly here and make that a negative x minus 1. And then as you see, the 1's will cancel and the x will cancel. And all I'm left with in the numerator is delta x. Well, when that happens, I can cancel the delta x with a delta x in the denominator because this is multiplication right here. And that then gives me the limit as delta x goes to 0 of, the numerator is now simply 1, over the square root of x plus delta x plus 1 plus the square root of x plus 1. Now if delta x goes to 0, I end up with the square root, well, let me write that one more time. If I take this limit, delta x goes to 0, so what I get is 1 over the square root of x plus 1 plus the square root of x plus 1, which is obviously 1 over 2 times the square root of x plus 1. Now notice here in this step right here, I dropped the limit because I took the limit here. I let delta x go to 0, and that left me with x and 1. So I took the limit. There's no reason to put the limit down here anymore because I already took the limit. Every other step I needed limit and limit, except for where I denoted that was simply doing algebra. So this is a function. This is actually called the derivative function. Which is f prime of x. So f prime of x actually equals 1 over 2 times the square root of x plus 1. And then it said to find it for the point 3, 2. So I want to evaluate this at x equals 3. And when I do, I'll get 1 over 4. Because 3 plus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. So there's the slope of this function at the point 3, 2. So now what I want to do is I want to switch to Maple and graph these two functions and see if it seems reasonable. So I will tell Maple to plot. I need the square root of x plus 1. Oops, I'm going to plot more than one function, so I need these curly brackets there. There we go. Comma. And the derivative function, 1 over 2 times the square root of x plus 1. And I'm going to let x go from, see, -1 to, I think 5 should be plenty. We may need to adjust that a little bit. I don't know. Y, I'm going to go from -1 to, I don't know, 5, or let's do 6. Somewhere in there should be fine. And, I'm going to make this a little bit thicker. There. Okay, so let me make this a little bit bigger. I'm going to look at these two functions and say, all right, which is the original function and which is the derivative? So, I'm going to change this x here to -2 just so you can see what's going on over here. There's actually nothing going on, but I want you to see that there's nothing going on. There we go. Okay, this is the square root of x plus 1. Because when x is equal to a -1, I get square root of 0, which is 0. And there's my original function. Now, looking here, what is the derivative tell me? Well, the value of the derivative, okay, this is important now. The value of the derivative is telling me the slope of the tangent line. Okay, it's the slope of the tangent line. So, here, the slope is going to be, right here, slope is going to be 5. So at this point on my function, I'm going to have a pretty steep slope of 5. Over here, let's say right there, what this is telling me is that my slope right here is going to be equal to, it looks like about a half. Now we were interested in the point 2, 3. So when x is 2, then, I'm sorry, 3, 2. When x is 3, f is 2, but what's the value of the slope here? Well, the slope is going to be, the slope of the tangent line is going to be the value here, which looks like it's less than a half. Looks like it's in between somewhere. It looks like the 1/4 that we claimed was pretty reasonable. So let's go back for a moment. Now that we know that the slope is a 1/4, I have the point 3, 2. Let's find the equation of the actual tangent line. So I have the point 3, 2, and I know that slope is equal to 1/4. So I'm going to use y minus y1 equals the slope times x minus x1. So y minus y1 is 2 equals the slope 1/4 times x minus x1, which is 3. So y equals x over 4 minus 3 over 4 plus 2. Now plus 2, I'm going to need to do the addition here. So that's actually the same as, and I'm going to change it right away. Oops. To 8 over 4. There we go. So this is going to be x over 4 plus 5 over 4. This is the equation of the tangent line. So let's add this to Maple and see what we get. So back here in Maple, all I'm going to do is I'm going to simply add that one function. Put a comma there, and x divided by 4 plus 5 over 4. So now I'm going to end up with 3 different functions. And here's my tangent. Here's my tangent line right here. And the slope of the tangent line when x equals 3, the slope should be, well, it is 1/4, because that's what I did the equation at. So here's the tangent line. Here's actually the derivative function, which is something we haven't actually looked at before. The function of x that represents our derivative. And any value here, for any x, the derivative function would tell me the value of the slope of the tangent line. So x equals 3, the derivative function is 1/4, and that is the slope of this tangent line right here at the point 3, 2.